Hi, in this video we're going to be dealing with past exam papers from ZIMSEC questions, particularly focused on sets. So this will be focused on questions that have covered sets in the past exam papers. So for this first question, we are given that a universal set has -3, square root of 1.5, square root of 36, square root of 13, square root of 6.25, square root of root 64 divided by 16. Q complement is a set of irrational numbers and Z is a set of integers. List the elements of Q complement and Z. So the first thing is to try to simplify what's in the universal set, right? So we have -3 square root of 1.5 square root of 36 square root of 13 square root of 6.25 and square root of 64/16. And when you simplify that, you will get -3, then 1.5 as a fraction, as an improper fraction, becomes 2 times 1, that's 2 plus 1, that's 3/2. Square root of 36 becomes 6, since 6 times 6 is 36, and then we have square root of 13. Then square root of 6.25 is a improper fraction. It's 4 times 6, 24 plus 1, that is 25/4, right? And then 64 divided by 16, that is 4, becomes square root of 4. And when you look at this, we have other numbers under the square root that can be further simplified. So we further simplified such that we have -3 square root of 3/2, 6 square root of 13, 25/4. Both 25 and 4, the numerator and the denominator, are perfect squares. 25 is 5 squared, 4 is 2 squared. So removing the square root becomes 5/2. Square root of 4 is 2, right? So now we look at our question A, which means if Q complement is a set of irrational numbers, we have to remember that irrational numbers are numbers which cannot be expressed as a fraction of integers, right? For example, we have 3/2, right? And square root of 13. Or if you want to write it as it was before, that's square root of 1.5 and square root of 13. So that'll be the answer. Then B, Z, the set of integers, right? So if Z is a set of integers, when we look at integers, we have -3, which is a negative integer. We have 6, because integers are just whole numbers, right? And we also have 2, right? And when we put them in the format that they were at before, we have -3 square root of 36 and square root of 64/16. And that's how we get the answer for part A and B. And then November 2006, paper 2 said, number 3, in a class of 40, every pupil studies at least one of the subjects: mathematics, geography, and accounts. 4 pupils study mathematics and geography, 5 study mathematics and accounts, 7 study geography and accounts, 15 study mathematics only, 13 study geography only, 4 study accounts only. Find the number of pupils who study all 3 subjects. So what's important here is to understand that, first thing, the universal set has 40 students, right? And we have 3 subjects. So you first have to draw your Venn diagram. So we have those who are doing geography, those who are doing accounting, and those who are doing mathematics. And these have an intersection of some sort. and we have the universal set. So now let's write them down. So we have mathematics, we have geography, and we have accounting. So we're told that 4 study geography and mathematics. So let's make the common term x, which is what we're trying to find. If 4 study geo and maths, it means that 4 minus x study maths and geography only, right? And then 5 study mathematics and account. So mathematics and account minus x, because that's the intersection of maths and account only, which we have not been told. And then 7 study geography and accounts. So 7 minus x as well is right there. But 15 study mathematics only. And 13 study geography only. And 4 study accounts only. So now we've been asked to find those who study all 3 subjects. So now we're trying to find x, right? Knowing that we have 40. So if we have to add everything up, 40 would be equal to 15 plus 4 minus x plus x plus 5 minus x, who study accounting and math only, plus 4, who study accounting only, plus 7 minus x, who study math and just geography and accounting only, plus 13, who study geography only, right? And when we simplify this, it becomes 15 plus 4 minus x plus 5 minus x plus 4 plus 7 minus x plus 13. And when we add them up, it becomes 48 minus 2x. Sorry, 48 minus 2x is equal to 40. And to simplify this, we can have minus 2 cross the equal sign and 40 cross the equal sign. And in so doing, we get 2x is equal to 48 minus 40, such that we have 2x is equal to 8 and x is equal to 4. So that's how many? That's 4 students who study all 3 subjects. That's how we simplify that. And then the next one, we have November 2008, paper 1. So it says, the Venn diagram shows the universal set x and set y. The letters u, v, w, and z represent the numbers of elements in each subset. It is given that the number of elements in the universal set is 150, number in x is 55, number in y is 32. Find the smallest possible value of z. So z is what is outside of x and y, right? But is still part of the universal set. So it says the smallest possible value, right? So if we want to represent what we have been told, just the same set, we have x and we have y. And we have the universal set, and we know that if number of x is, let's say, 55, right, minus the complement, which is in this case is v, right, because that's the union, sorry, of x and y, and w will be, sorry, y will be 32 minus the v, and then w is, z is outside of this. Now we're being asked, what is the smallest possible value of z? So to understand the smallest possible value of z can be as small if we maximize on this v. If v is as little as possible, then z can be as smallest as possible as well, because v takes away from x and y. So because those are the elements that are repeated, right? So if we subtract them from x and y, that means that the universal set, like z, becomes the universal set minus x and y, which would be a smaller number. So the smallest possible of z is when v is equal to 0, right? Such that z would be equal to the universal set, which is 150, right? Minus, if v is 0, x will be 55 and y will be 32. And that becomes 150 minus 87. When you simplify that, you get 63. Because all we're saying is, in better explained in Shana, if a number is already in x and y, it goes into v. So ikadzokorodzwa muna v, that means that we would otherwise minimize the number of elements that go on z. So as long as there is no union between x and y, there are less numbers that are going to go to z, right? So that's why the smallest number is when the intersection of x and y is the smallest, which is going to be v equal to 0. Part B then says, find the largest possible value of v. So largest possible value of v is equal to 32. Since y can only be 32 minus v, v cannot be anything greater than 32. So if everything in y is in the union, it's in the intersection of x and y, which is 32, then that's the largest value of v, right? It can't be 55 because y doesn't have 55 things. So the smallest one, which is y, has 32 elements. Saka, the largest possible value of v is when everything in y is in x. So then v becomes 32. So that's the answer. Then part C says, value of w if u is 45. If u is equal to 45. So remember, u is the number of elements in x, right? When you look at it, that's what in x only, right? The number of elements in x only. So that means it's 45. Therefore, number of elements in x all in all will be, we know that that's 55, right? Such that v is equal to 55 minus u, which should be equal to 55 minus 45, which is 10, right? Because when we look at this, we know that u, now they're saying if u is 45, we know what's in x, the whole of x, that is 55 we were given. So that means that v will be equal to 10. So once we know v and we know everything that's in y, which is 32, we can find w as well. So w, therefore w is equal to 32 minus 10, right? Because it's also minus v, which is equal to 22. So that's how we calculate it. Then the next question is from June 2011, paper 1, which says, in the Venn diagram, RST and the universal set are sets with their elements as shown. Use the Venn diagram to find R complement E intersection S. So let's look at R complement intersection S. So it says everything that's not in R being intersected with something that is in S. So then that becomes everything that's not in R. If we had to shade this with green, so this is everything that's not in R, right? Then they say intersection with everything that is an S. So when we then look at what's an S, we shade that with blue. So where the blue and green match, there's only 6. So that means it's 6. Right. Then the next question says R intersection S union R intersection T, right? So let's find R intersection S. R intersection S, that's here, shaded in blue. And then R intersection T, that's here, shaded in green. So now they're asking the union, which means everything included in those two sets. So that would be 4, 7, and 8. Perfect. And then the next question says number of elements in R union S union T complement. Great. So R union S union T is all 3 sets that are highlighted. The complement is outside, so that's these. And the number of elements in here are 11 and 12, which is just 2. So that is 2 because there are only 2 elements in there. That's the answer. Then we go to June 2008, paper 1, which says the Venn diagram shows the universal set and the sets P, Q, and R with their numbers. From the Venn diagram, list the members of P intersection Q. So, P intersection Q is everything that is in Q because Q is contained in P, right? So that is going to be A, B, and C. And then the next question says P complement intersection Q complement. So when we look at P complement, that is being shaded in green. That is P complement. And then Q complement, if we shade it in blue, so that's everything here. Now we are asking, where do those two find an intersection, right? So that's going to be everything, including H, I, and K, right? And then now we have find the number of elements in P. So counting the number of elements in P, we have F, A, B, C, D, E, and D, and E. Sorry, so that's going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. That's equal to 7. Perfect. Then we go to the next question, which is from June 2008, paper 2. It is given that the universal set is all triangles. A is all equilateral triangles. A is a set of all equilateral triangles. B is a set of all isosceles triangles. And C is a set of all right angle triangles. Draw a clearly labeled Venn diagram to illustrate the relationship between these sets. So we need to understand that equilateral triangles have all three sides that are equal, right? As isosceles triangles have two equal sides, right? So and then a right angle triangle is self-explanatory. It means that it forms a 90-degree angle, right? So here's a 90-degree angle. So if we're going to draw this, we have to understand that we have a universal set, which is all triangles, and we have B, which is isosceles triangles, right? But we have A because all equilateral triangles are isosceles, in that if it already has two equal sides, then it counts as isosceles. Although once it has a third one, then it's only equilateral. Not all isosceles triangles are equilateral, but all equilateral triangles can count as isosceles triangles because they have at least two equal sides. And then some right angle triangles are also isosceles, but not all right angle triangles are isosceles. So that's why we have C, and that's how you represent it. And then we have the next question, which is November 2008, paper 1. It says the Venn diagram is number 20. The Venn diagram shows the universal set X and set Y. The letters, oh, sorry, this is repeated. Okay, we have to skip that. Okay, sorry, June 2009, paper 1. Given that the universal set is an integer between 30 and 85, X is a multiple of 9, Q is a perfect square, and R is a set of 35, 45, 55, 65, 75, and 85. List the members of P and N intersection Q, right? And then find the number of elements in the universal set and find the number between Q and R. Great. So the first thing we have to try to understand is that P is a multiple of 9, right? So we're trying to look for multiples of 9 between 30 and 85, inclusive of 30 and 85, right? So now when we look at this, we have 36, 45, 54, 63, 72, and 81, right? And then the next one says P intersection Q. So Q is a perfect square, so we need to understand which values are in Q, right? Perfect squares between 30 and 85. So we have 6 times 6, 36, 7 times 7, 49, 8 times 8, 64, 9 times 9 is 81. Those are the perfect squares that are between 30 and 85. So now P intersection Q, we're looking at what is common, right? So we have 36 is common and we have 81 is all as common numbers. So such that P intersection Q is going to be 36 and 81. The next question says, find the number of everything in the universal set. So to try understand this, let's say we have numbers. Let's say x is between 1 and 10, including 1 and 10. If you want to find the numbers, right, we can either write them down, which would be like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Or we say 10 minus 1, right, plus 1, because they are including, right, including both terms 10 and 1, such that we get 9 plus 1, right, which is 10. So likewise, we do that as well in this case, where we were told that the universal set is between 30 and 85 inclusive, right? So that means the number in the universal set is 85 minus 30 plus 1, because it's going to be n plus 1 inclusive, right? So that will be 55 plus 1, which is 56. Unless if you want to write down all the numbers between 30, 31, 32, 30, 34, 35, 36, 37, until you include 85, up to and including 85. So this is one of the shortcuts. Then it says number of n of q intersection r. So we look at q and r, and let's see what's common. So we actually have nothing in common between q and r. So the number of q intersection r is 0. Okay, perfect. Then we got the next question, which is June 2009. Paper 2. It says, in the Venn diagram, P, Q, and R are sets such that P union Q union R is a universal set. The number of elements is shown in each region. Find number of elements in R. So number of elements in R is equal to 7 plus 2 plus x plus 18 minus x. Expanding this is 7 plus 2, which is going to be 9, plus x plus 18, which is going to be 27, minus x. X minus x will cancel, such that we have 7 plus 2, 9 plus 18, that's 27. And then part 2 says, given that NQ is equal to 40, find the value of x. So the number in Q, so in Q we have 10, x, 18 minus x, 14 minus x. So 40 is equal to 10 plus x plus 18 minus x plus 14 minus x, right? All right, so we have 40 being equal to 10 plus x plus 18 minus x plus 14 minus x. And we end up x minus x, that becomes 0, it's equal to 14, is equal to 10 plus 18, that's 28, plus 14, that is 42, minus x. And x crosses the equal sign, 40 crosses the equal sign, such that it becomes minus x becomes positive x is equal to 42 minus 40, and x is equal to 2. And that's the solution. So then it says, hence calculate the value of number of P union R intersection Q complement. So to try understand this, let's find what Q complement is. Everything outside of Q, right? Intersection with R, that's everything in R. So just to understand this first part, sorry, let me write that in green. So R intersection Q complement is this. Now with the union of P, that is this. Right? So we know that x is 2. So now that is part 3. Number of P union R intersection Q complement, right, is equal to, so that's the shaded part. We have 2 plus 7 plus that x, which we now know is 2, plus the x plus 3, which is in P, which is going to be 5, plus the 10, which is in P as well, which will be equal to 2 plus 7, that's 9, plus, did I leave something out? No. Let me see, 1 2 3 4 5 numbers, 1 2 3 4 5 numbers. Okay, so 2 plus 7, that's 9, plus 2, that's 11, plus 5, that's 16, plus 10, that's 26. And that's the answer. The next question, November 2009, paper 1. So among the number of staff at a school, 21 take tea, 12 take coffee, 5 take neither tea nor coffee, and X take both tea and coffee. So complete the Venn diagram to show the elements in each subset. So I'm going to fill this in blue. X take both tea and coffee. 21 take tea, so that's going to be 21 minus X. 12 take coffee, that's going to be 12 minus X. 5 take neither, so 5 is going to be there. So that's the first question. If there are 35 members of staff, find the value of X. So if 35 is the total, value of X is going to be tea only, which is 21 minus X, plus tea and coffee, which is X, plus coffee only, which is 12 minus X, plus neither, which is 5. 35 would then be equal to 21 minus X plus X plus 12 minus X plus 5, such that is equal to 35 is equal to, minus X plus X, that's going to be 0. 21 plus 12, that's going to be 33, plus 5, that's going to be 38, minus X, right? Again, minus X crosses the equal sign such that it's positive. 35 crosses the equal sign, and then making X subject of formula, X is equal to 38 minus 35. and x is equal to 3. So that's how many drink both coffee and tea. So part 2 says the actual number of members of staff will take tea but not coffee. So that's tea only, which is number of tea only is equal to 21 minus x. We know that x is 3, so that's going to be 21 minus 3, and that is 18. That's the answer. Then the next question says, write down, that's from November 2009, paper 2. Write down in set notation the set represented by the shaded region in the Venn diagram. So that Venn diagram is, we have A complement intersecting with B union C, because B union C are both shaded, and then A complement would have been everything outside of A, including what's in the universal set, but it's an intersection of B union C now. So that's the answer. And then we go to June 2010, which says, given that the universal set is 25, number in A is 12, number in B complement is 6, number in A union B complement is 2, complete the Venn diagram. To show the number of elements in each subset. So the universal set we're told is 25, number in A is 12, right? So we know if this is x, we have 12. Number in A union B complement is 2. So that's the number outside of A and B. Number in B complement is 6. So this is 12 minus 6. And we don't know what's in B. Let's call it y, right? So firstly, we can find number of B complement. So to find B complement, I'll shade it in blue. So B complement is basically this. Right, that is B complement. So to find B complement, we know that that is equal to 6, which is 2 plus 12 minus x. 12 minus x, which will then translate to 6 equal to 2 plus 12 minus x. 6 equal to 14 minus x, which means x is equal to 14 minus 6. And that's 8. So if x is 8, so we now have 8 here, and here would 12 minus a will be 12, a only will be 12 minus 8, which is going to be 4. And we know that we have 2 outside. So if we want to find the number of elements in B, given that we know that the universal set has 25, which should be 4 plus 8 plus y, which is number in B, right, plus 2. 25 is equal to 4 plus 8, that's 12 plus 2, 14 plus y. So y is equal to 25 minus 14, which then makes it 11, right? So that's number in B, that is 11. So that's how you find it. we'll continue with the next questions in the next video.